Okay, so we will come to that, your homogeneity property. So basically it requires that if the input, that is called excitation, is multiplied by constant, then the output, it is called response, is multiplied by the same constant. That is I have underlined, right. For example, for a just hold on. For example, for a resistor, Ohm's law relates the input current I to the voltage V. So V is equal to IR. Now, if the current is increased, or in bracket I have written down, or decreased by constant K, the voltage increases or decreases correspondingly by K, that is Ki into R is equal to Kv. So this is equation 2, right. So, it is chapter 4.2, but I will say 2, 3 like this, right. So, and the additivity property, it requires that the response to a sum of the input, right, is the sum of the responses to each input applied separately. Suppose input, you have your input, you have your what you call more than one input is there, and then output you are getting a response by adding all this input. Now, if you consider one at a time at the input and output responses you are getting and sum it up, if it is equal to the same as your sum of the inputs, so together you are putting at the input and getting the output response. So, additivity property is, it requires that the response to a sum of inputs to the sum of the responses to each input applied separately. I mean, suppose that the input you have many, your what you call many inputs are there. So, consider one at a time and output response you are getting and add this one. Now again at the input, all the inputs are there, get output response, these two must be your equal, right. So, that is called actually the additivity property. So, using the voltage current relationship of a resistor, say if V1 is equal to I1 into R, right, and V2 is equal to say I2 into R, right. By applying I1 plus I2, it gives V is equal to I1 plus I2 into R, that is I1R plus I2R. That means V is equal to your V1 plus V2. This is additivity property, right. So, that is this condition has to be your what you call satisfied. So, therefore, we can say that a resistor is a linear element, because its voltage current relationships satisfied both homogeneity and additivity properties, right. Then only you can say that element is linear, it has to satisfy both homogeneity and additivity properties, right. So, then you can say that it is a linear element. In general, a circuit is a linear if it is both homogeneous and additive, right. So, a linear circuit consists only linear elements. So, linear dependent sources and independent sources. So, if I underline it for you, so a linear circuit consists only linear elements, linear dependent sources and independent sources. In other words, all these are all are underlined. A linear circuit is one whose output is directly proportional to its input, right. Output is directly proportional to its input, then the circuit is called a linear circuit. But note that power P is equal to I square R is equal to V square upon R, right. It is your what you call, it is non-linear, right. So, power voltage relationship is non-linear. So, it is I have written somewhere in this book is not written actually, it will be chapter, the book never completed actually. So, it will be chapter. So, in this chapter we consider only linear circuits, and theorems covered in this chapter are not applicable to non-linear circuits. So, let me clear it, right. So, in this case, so not applicable to your power, right. So, only we will go for linear circuit. So, for the purpose of explaining the linearity principle, you consider this figure 1, right. So, you have one voltage source and you have one voltage source, and here one left hand side one resistor, load resistance is R and current is flowing through it, and in between the linear circuit without independence, in between your what you call this portion is a linear circuit, but without independent sources, and this is voltage and this is your what you call, this is your one load resistance R is there, current flowing through it is I, right. Now, question is that suppose if my V is equal to 5 volt, at that time say I is equal to 1 ampere, right. If I make it V is equal to 10 volt, then I has to be 2 ampere, because V has been multiplied by 2. So, I has to be multiplied by 2. If it happens, then a circuit is a linear, right. So, that property has to be your what you call satisfied. So, in this case the linear circuit is excited by voltage source V. I told you we serve here it is voltage source V which serves as the input, and the circuit is your terminated by load resistance R. So, I told you if the V is high, for example, suppose here I have taken whatever I said same thing. Suppose if V is 100 volts, say at that time current is 20 ampere, but if we make V is equal to 10 volt, the current will be 2 ampere, right, because we are multiplying K is equal to say by 0.1, right. So, that is that linear your what you call, then you can say that it is linearity principle. According to that it condition has to be satisfied, right. So, next is determine I0 when V is equal to 3 volt and V is equal to 6 volt of the circuit shown in figure 2, right. So, in this case you have one dependent voltage source Vx. Look, throughout this all these equations KVL, KCL all we have studied now, right. So, in this case this voltage is Vx and one dependent voltage source is there Vx, right. So, this Vx actually Vx is equal to actually 2 into your I1, this is my Vx, right. So, in this case what you can do is you apply your, and if you see there are two mesh in between your what you call one here, of course one voltage source is there, it is not a current source. So, you apply KVL and accordingly you solve this one, right, and prove that whether it is circuit is a linear or not. So, let me clear it. So, in this case we apply KVL. So, this circuit please, this is mesh 1 and mesh 2, you apply KVL. So, not telling it again and again, it is understandable to you, and this current is I0, this current is here, it is marked that this current is your I0, here the current is I0, right. So, let me clear it. So, KVL if you apply, so two meshes you will get two equations, right. One is 12 I1 minus 4 I2 plus V is equal to 0, and then you will get minus 4 I1 plus 16 I2 minus V minus Vx is equal to 0, but Vx is equal to 2 I1, right. If you look into that, this voltage is V and it is given once you find out I0 when V is equal to 3 volt and when V is equal to 6 volt. So, now after getting this, when V is equal to 3 volt, you solve the circuit, you will get I0 is equal to 3 by 28 ampere, right, and when V is equal to 6 volt, you see I0 is equal to 6 by your what you call 28 ampere, right. So, that means when it is 3 volt, it is 3 by 28, when it is 6 volt, voltage is double, current also double, 6 by 28 ampere. So, this clearly shows that when source voltage is double, I0 also doubles and the circuit is a linear circuit, right. So, similarly another one you take that determine V0 when I is equal to 5 ampere and I is equal to 10 ampere of the circuit. So, your what you call this I actually is a current source, a current source is given, you find out your what you call V0, this voltage is V0. So, V0 is equal to actually 4 into your I2, this is V0, right, and in this case is you have to find out V0 when I is equal to 5 ampere. So, this I is 5 ampere, another case when I is equal to 10 ampere, and if 5 ampere to 10 ampere means the current getting doubled, naturally V0 also when you solve it, it has to be doubled, right. So, accordingly you please solve it. So, this current is I is this direction is 5 ampere, that this is your I1, same direction. So, basically I1 is equal to I or I is equal to I1, right. So, let me clear it. So, if you apply then your what you call KVL in your what you call mesh 2, you apply KVL in mesh 2. So, I1 is equal to I told you, and 12 I2 minus 2 I1 is equal to 0. So, all I am not writing here, it is understandable to you, right. You apply KVL in mesh 2. So, I2 is equal to I1 by 6. So, V0 is equal to 4 I2. So, when I is equal to 5 ampere, right. So, then means I1 also is equal to 5 ampere. I told you I is equal to I1. Therefore, I2 is equal to I1 by 6. So, here it is given. So, here it is given that I2 is equal to your 5 by 6 ampere, and V0 also I told you for your 4 by 2, 4 I2, and V0 is equal to that I2 is equal to 20 by 6 volt. Now, when I is equal to 10 ampere, so I1 also 10 ampere. So, I2 is equal to I1 by 6, so 10 by 6 ampere. So, V0 is equal to then 4 I1, so it is 40 by 60 volt. So, it was 20 by 60 volt when current was 5 ampere, I is equal to 5 ampere. When I was made 10, that is double, so voltage also has become double. So, from that you can tell the circuit is a linear, right. So, next is superposition principle. So, this is something like this. So, if a circuit has two or more independent sources, one can determine the contribution of each independent source to the variable and then add them up. Suppose you have two or more independent sources, then you consider one at a time, other sources should be your turn off, right, and you add them up. Then this approach is known as a superposition. So, idea of superposition rests on the linearity property, right. So, then I have underlined it. The superposition principle states that the current through or voltage across current through an element or voltage across an element. That is why in the bracket I write down I current through or voltage across, right, an element in a linear circuit is the algebraic sum of the current through or voltage across that element due to each independent source acting alone, right. I mean, whenever you are applying superposition, you consider only one source at a time, independent source, right, only independent source. If it is a dependent source, they will remain intact in the circuit, right, you cannot turn them off. So, later we will see, and that means if consider one at a time, then either current through an element or voltage across an element, independently you made it, and then you add it up, whatever you will get, you solve the circuit as a whole, you will get the same thing, right, that is superposition. Only thing is that superposition case this approach is good, but it will compute your it will consume your more time, right. So, that means your to apply the superposition, two things must kept in our mind, right. One thing is you consider one independent source, that is you consider one independent source at a time, right, only one independent at a time, and all other independent sources are turned off, right. This means we replace every voltage source by 0 volt, that means you short circuit, that voltage source should be short circuit, and every current source by 0 ampere, that is it is an open circuit, right. We will see later in the taking example, few example we will take, thus we obtain a simpler and more manageable circuit. Then if it is a voltage source, you short circuit, consider one at a time, and if it is a current source, you open it, right, such that, because you have to consider only one source at a time, right. And dependent sources are controlled by variables, and hence they are left intact. So, but if dependent sources are there, you just cannot turn it off, right, because their values are dependent on the your what we call current or voltages, right. So, they will remain intact. How we will see later, right. So, circuit analysis using superposition may very likely involve more work, and this is a major disadvantage. Superposition is based on linearity, and this reason it is not applicable to the effect on power due to each source, because the power absorbed by resistor depends on the square of the voltage or the square of the current. So, it is not applicable for the power, but for the voltage and current it is applicable, right. So, using superposition theorem, determine V in the circuit shown in figure, this thing, right. You have to find out what is the you have to find out that your voltage V in general, V is equal to 2I, that is in general, right, because this is the current I is flowing, and using superposition theorem you have to make one voltage source is there, independent voltage source is there 12 volt, and one independent current source there is 6 ampere, right. So, now how we will do it? First thing is, for making your applying superposition theorem, what we will do it, once we will take only one source at a time. Look how we can make it. So, in this case, when current source is turned off, that is your 6 ampere source is turned off, then this is the circuit, this is the circuit, that is your this is the circuit when 6 ampere at that time current is I1, current is flowing through this is I1 we have taken, right, and when current source is there, that voltage source, the 12 volt voltage source, this current source is there now, and 12 volt voltage source is short circuit, one at a time. If it is a current source, it has to open. If it is a voltage source, it has to be short, right. At that time, current is taken here is I 3, for this branch it is taken as I 3, right. That means in that the current earlier in the circuit, your I actually is equal to your I 1 plus your I 3, right, because this is your what you call this is the, and voltage V is equal to this voltage V 1, because superposition, then this voltage V 2, right. So, earlier in the circuit, actually just let me go to the circuit, right. So, here this is the current I. So, after getting these two different circuit because of superposition theorem. So, now in this case, for 2 ohm resistance, when current source is open, it is current I 1, and when your voltage source is shorted, but current source is there I 3. So, basically I is equal to your I 1 plus I 3, and V 1 is equal to your 2 into I 1, and V 2 is equal to 2 into I 3, and V is equal to V 1 plus V 2, because here it is, because we are taking one source at a time, here it is V 1, here it is V 2. So, basically it will become V 1 plus V 2, right. So, before moving this, so in this case it is very easy to find out what is the I 1 current. So, if you apply KVL here, it will be 4 plus 2, it is a simple circuit, right, nothing is here. So, basically 6 I 1 is equal to 12, therefore, I 1 is equal to 2 ampere for this one, right. So, that means V 1 is equal to 2 I 1, right. So, I 1 is equal to 2 ampere. So, that means V 1 is equal to 2 into 2 is equal to 4 volt, right. This is your V 1, right. Similarly, you just let us clear it. Similarly, if you solve this circuit, it is a basically we have at the beginning we have studied current division method, right. So, this is basically a parallel circuit, this 4 ohm and this 2 ohm, they are in parallel, right, and 6 ampere current is entering here, this 4 ohm and 2 ohm are in parallel. Then what will be, then if current division method, what will be I 3? Directly I can write I 3 is equal to, right. So, it is through this you have to find out I 3. So, this resistance is 4. So, 4 by 4 plus 2, this is 4 and this is 2 into your 6. So, that is actually 4 ampere. So, I 3 is equal to 4 ampere. Directly from the current division method you can find it out, right. And if I 3 is equal to 4 ampere, then V 2 is equal to your 2 into I 3, that is 2 into 4, that is your 8 volt, right. So, here we got V 1 is equal to 4 volt, right, and here we got V 2 is equal to 8 volt. Then what is V then? V will be is equal to V 1 plus V 2, that is 4 plus 8, that is your 12 volt, right. So, that is this is V as per superposition theorem, but you have to verify by solving. Let me clear it, but you have to verify by solving this circuit. As a whole, you solve this circuit and find out that your what you call that this V is equal to 12 volt or not. This is also solved for here. So, whatever I said, everything is done for you. So, all these things are now for a check. You solve this, your I 1 plus I 3 is equal to 6 ampere and V is equal to 12 volt. So, checking the result, you can easily find out your this thing what you call, you solve this circuit, right, and see that I here you will get I is equal to 6 ampere, because while solving here look here we got I 1 is equal to your 2 ampere, right, and while solving here you got for this circuit we got I 3 is equal to 4 ampere, right. So, I is equal to superposition theorem, that I is equal to actually I 1 plus I 3 is equal to 2 plus 4 is equal to 6 ampere, right, and if it is I is equal to 6 ampere, then the resistance was 2 ohm. So, 2 into 6 is equal to 12 volt, right. So, let me clear it, and that means this circuit you solve, you find out you will get I is equal to 6 ampere and V is equal to 6 into 12 volt. So, all these things we have done it. So, that means your what you call here it is given V is equal to 12 volt. So, problem is solved. right, superposition theorem and your as a whole if you solve the circuit. Now, next one is using superposition theorem determine Ix in the circuit in figure 4. So, in this case you have to find out what is the Ix using superposition theorem. So, that means this Ix you have to find out, and one dependent voltage source is there 5 into Ix. As I told you, the dependent voltage source you cannot, it should be intact in the circuit, you cannot remove it, now you cannot turn it off, right. But one independent current source is there 4 ampere and one independent voltage source is there 20 volt. All others are resistance values are given. We have to find out your what you call Ix using superposition theorem, right. So, in that case what we will do, we will consider one source at a time, once we will consider this voltage source, once we consider the current source, right. When we consider the voltage source, this will be open, when we will consider current source, this will be shorted, but at that time each case Ix will change. So, Ix basically, say for example, Ix will become say Ix dash plus Ix double dash, right. This is equal to, right. So, how? Let us see. Just hold on. So, in this case, that the circuit is that I told you has a dependent voltage which must be left intact, that is Ix should be equal to Ix dash plus Ix double dash. Now, Ix dash is equal to current through 5 ohm resistors due to 4 ampere current source only as shown in figure 4.7. Now, superposition we are applying. So, this voltage source is shorted here, right here. So, voltage source is shorted here, we have shorted only current. When 4 ampere current source is only there, at that time this is the current Ix dash, right. I told you Ix is equal to Ix dash plus Ix double dash, right. And similarly, and as per all the mesh your what you call that I1, I2, I3 is shown, and here also the dependent, this dependence here also it will be 5 into Ix dash, right. So, it is not Ix now, it is Ix dash. Similarly, when voltage source is there, right, when voltage source is there, current source is not there, look, current source is not there, it is open, right, at that time it is Ix double dash, right, and here also it is your 5 into Ix double dash. So, that means this circuit and that circuit you have to solve for Ix dash and Ix double dash, then you add it up and as a whole you solve the circuit, you will get the same answer, right. So, let me clear it. So, that means first you have to solve this circuit, right, you have to solve this circuit. One thing is there that all these things are written, that there is a node A, right. So, this 4 ampere current is going like this. So, this will be your 4 ampere, right, and this I3 current clockwise we have taken. So, this I3 also entering into the node and Ix dash also entering into the node. So, if you apply KCL at node A, so it will become your I3 plus Ix dash, both current are entering into the node and 4 ampere is leaving, and this is your 4, right. So, in this case what your what you call this KCL is needed for solving this circuit. So, let me clear it. So, for this one your similarly for your this I1 is equal to 4 ampere. If you see this mesh one, this I1 is equal to 4 ampere, because here where you are moving like this. So, this 4 ampere in this upward direction. So, I1 is equal to 4 ampere, right. So, rest you can easily apply your what you call your what you call that your KVL and KCL also at this node I told you, and accordingly you can solve the circuit. So, all these things are given. So, if you then this is your what you call circuit 4.7a and this is circuit 7b. So, accordingly for mesh 2 when you apply KVL you will get the equation 3, here it is equation 3 you will get. Now, you please apply, because all this KVL, KCL you have gone through, right. Similarly, for mesh 3 you will get this your what you call minus this another equation for Ix dash, and at node A I told you apply your KCL, that is 4 minus Ix dash is 5. So, substitute equation 2 and 5 in equation 3 and 4, right. So, after giving two simultaneous equation, it will get, that is your 3 I 2 minus 2 I x dash is equal to 8 and I 2 plus 5 I x dash is 20. If you solve these two equations, you will get I x dash is equal to 52 by 17 ampere, right. Now, to obtain I x double dash, again you turn off the 4 ampere current source we have seen. So, that circuit becomes that shown in figure 7b, that also we have shown. So, here also for mesh 4 you apply KVL. Here when I am taking this this circuit, this is we are calling mesh 4, right. This is your mesh 4, this is mesh 4 and this is mesh 5. You apply KVL here, right, both the cases, and just solve it. So, all these equations now you can write, right. So, if you do so, mesh 4, it will become 6 I 4 minus I 5 minus 5 I x double dash is equal to 0. Similarly, mesh 5 you write the equation and look at that mesh 5, it will become I 5 is equal to minus I x double dash, because direction you will just see upward and downward, right. So, substituting this in equation 9 and 10, you will get this equation, that 6 I 4 minus 4 I x dash is equal to 0, right, and this one is equal to minus 20. Solve this, you will get I x double dash is equal to minus 16 upon 17 ampere. Therefore, I x is equal to I x dash plus I x double dash is equal to minus 8 upon 17 ampere. If you solve this one, this circuit, you will get the same answer, minus 18 upon 17 ampere, right. Just one here, see one more simple example. Determine I using superposition theorem of the circuit shown in figure. There are three sources, two independent voltage sources, one independent current source, right, one independent current source. So, take one at a time. So, first you two voltage sources are shorted, only current source is there. So, this is a simple thing, right, because 6 ohm and 8 ohm both are in your what you call your series. If you look into that, both are in series. So, 6 plus 8 is actually 14 ohm, but anyway you have to find out the current I 1 through this circuit, 8 ohm this thing, and when the first case the current is I 1, because I is equal to I 1 plus I 2 plus I 3, right. Similarly, when current, then the 16 volt source is taken, but current source is open and another voltage source is shorted. Similarly, for the third one, the 12 volt source is there, current source is open, another voltage is shorted, right. So, this way one source at a time, rest will be turned off. So, this way if you find out, very simple here, I 1 is equal to, right. So, if you try to find out what will be your this thing I 1. So, this is your 8 ohm and 6 ohm, basically they are in series, and with that and that means this is your 14 ohm, right, and this is your 2 ohm, and with that this current source is there, 6 ampere. But basically all these three things are in parallel, right. So, then what will be I 1? So, it is current division method only. So, if you try to find out I 1 will be equal to 2 divided by 2 plus 14, right, into your 4 ampere, right. So, basically it will become 0.5 ampere, 4 by 16. So, it will be half. So, 2 into your 8 by 16, 0.5 ampere. So, I 1 will be 0.5 ampere, right. So, let me clear it, very easy. Similarly, here directly you will get it, what will be I 2? I 2 will be your, basically if you add 6, 2 and 8 all are in series. So, 16 your 16 ohm. So, your I 2 will be is equal to 16 by 16 is equal to 1 ampere in this direction, right. So, this is your 1 ampere. So, that is your I 2, and then your I 3. So, I 3 in this case, here in this case this 16 ohm your what you call is in series. So, basically if you if you apply your KVL, it will be 16 into I 3, then encountering plus terminal first 12 is equal to 0. Therefore, I 3 is equal to minus 3 by 4 ampere. So, minus here I am making it I 3 is equal to minus 0.75 ampere, right, because here is plus terminal is encountering first. If we apply KVL like this, so that means I is equal to superposition theorem I 1 plus I 2 plus I 3. So, in this case your all these things I have told, all these things that circuit A, B, C, everything I told, right, and I1 calculation also given, I2 I told, I3 also I told minus 0.75. If you apply superposition, I1 plus I2 plus I3, it will be 0.5 plus 1 minus 0.75 is equal to 0.75 ampere, that is I, right. I suggest that you solve this circuit as a whole, this considering all these sources, you solve this circuit, right, and see that you are getting same you are getting the same value whatever using superposition we have got. With this, thank you very much, we will be back.